Okay, today's lesson is 3-6, Multiplying Matrices. And before we get started on that, I wanted to remind you that what the dimensions of a matrix are. Remember, we always, when you're given the dimensions of a matrix, it's always rows by columns. And if you remember that, then that should help you remember how to multiply matrices. So this is what we do. When you multiply two matrices, they can only be multiplied together if the number of columns in the first matrix is equal to the number of rows in the second matrix. So here's an example. Down here we have matrix A that is an M by R, so that has M rows and R columns. And B is R by T, so it has R rows and T columns. And the only way that you can multiply those if these are the same number. And if they are the same number, then these outside numbers are what are going to be the dimensions of your new matrix. So when I multiply A times B, I'm going to end up with an M times a T. Okay, so let's go. So you got to remember that, because that's the first thing you should always do whenever you're multiplying matrices, okay? Unless they are square. If they're square, same dimensions, it's not really a problem. So we're supposed to determine whether each matrix product is defined. If so, state the dimensions of the product. So A is a 4 by 6, B is a 6 by 2. So I'm looking at these two inside numbers, and since they are the same, then it is defined. And what are the dimensions of the product? The dimensions of the product are going to be a 4 by 2. Okay, look at 1B. We have a 3 by 2 and a 3 by 2 and a 3 by 2. Okay, those inside numbers are not the same. So that means that this product is not possible. Okay, so first off, you got to figure out if the dimensions make the product possible. And if the dimensions do make the product possible, then this is how you're going to multiply them. Okay, so I tried to color code it to make it a little bit easier for you. It's all about, and actually I'll put that back in there. It's all about rows by columns again. So when I'm multiplying, and these happen to be square ones, so that's relatively simple. But I'm going to be multiplying the first row by the first column. Okay, so when I do that, if you will think about, I'm going to go do this element right here. This is the first row, second column. So I'm going to multiply the first row by the second column. So I'm always taking the rows of this one and the columns of that one. So first row, second column means I'm going to have A times F plus B times H. Okay, this one here is the second row, first column. Second row is CD, first column is EG. So I'm going to have CE plus DG. Okay, first row, first column, AE plus BG. And then for this last spot, that's going to be the second row, second column, which is CF plus DH. So we have a new set. We're multiplying square matrices. Okay, so find UV if U equals such and V equals such. Okay, get into the habit. You check to make sure that these inside, they're both 2 by 2s. The inside numbers are the same. The outside numbers are giving you the dimensions of your new matrix. Okay, so to figure that out, I'm going to do first row times first column. The order doesn't matter. Okay, you're doing the same thing every time. So if I know it's going to be a 2 by 2, all right, then I have my dimensions, my brackets to symbolize it. It's important that those brackets have a top and a bottom to them. Okay, so let's go with first row, first column. That's going to be 5 times 2 plus 9 times 6. Okay, if I go across, that element across is first row, second column. That's 5 times -1 plus 9 times -5. Always put parentheses around your negatives. And I would encourage you to not change this right here. Even if you were to write the products, okay, if you wrote -5 and -45, I would keep that as a plus sign because we're going to come up with several different rules like this, and people tend to get them confused if they try to go ahead and make that change. Okay, so this is second row, first column, so that's -3 times 2 plus -2 times 6. And then second row, second column is -3 times -1 and -2 times -5. So when you combine each of those elements, you get an answer of 64, -50, -18, and 13. Okay, just simplifying each of those. So when you show me your homework, okay, you can either write this out like that. You can either write 5 times 2 plus 9 times 6, or I need you to write 10 plus 54, -5 plus -45. So whichever one, that is the least amount. You can write another step if you want to, but if you want full credit for your homework, make sure you write something, some kind of middle step before you give me that final answer. Okay. This is an example of some things we have to do with matrices. Determine if A times B equals B times A. Is that true for these two matrices? So if I do A times B, okay, they're both square, 2 by 2s, so we're good. We know the answer is going to be a 2 by 2. So my first row, first column is 4 times excuse me, 4 times -3. I'm going to pause a second, y'all. Okay, so now you know I made it. All right, so back to, let's go with, we're doing here. I want to make sure that's good. That's good. All right. I'm going to show you a different way of writing it. So I'm doing first row, first column. Okay. So for this first element here, so that's going to be 4 times -3, which is -12, and then -1 times -4. This is why I'm encouraging you to always put plus 4. So -4 plus 4, excuse me, not -4, -12 plus 4 is -8. Okay. If I go to the first row, second column, then I'm going to have 4 times 6, which is 24, plus -1 times 5, that doesn't look like a plus -1 times 5, which is -5. So this is the one I would encourage you not to write that as 24 minus 5. You need to know that you're always multiplying and then adding when you multiply matrices. So 24 plus -5 is 19. Okay. Then I have second row, first column. So 5 times -3 plus -2 times -4, which is +8. And -15 plus +8 is -7. And then this last one would be second row, second column. So 5 times 6 is 30 plus -2 times 5, which is -10. -10, and 30 plus -10 is 20. So A times B is 20. Now B times A. I'm telling you, y'all have been doing this a long time, and I would not multiply B times A without writing A on that side of B, just because it just messes with your brain to try to do it in a different order. Okay, so let's go with, I'll go with this color here. Okay, so first row, first column is going to be -12 plus 30, and -12 plus 30 is 18. Then first row, second column, -3 times -1, and plus 6 times -2, and 3 plus -12 is -9. Second row, first column, -16 plus 5 times 5 is 25, and -16 plus 25 is 9. And then -4 times -1 is +4 plus 5 times -2, which is -10. And 4 plus -10 is -6. So determine whether or not they're true. Well, we just found out that A times B does not equal B times A. That is an example. I hope you know. Remember the commutative property. So this is a really, really important property for you to remember, is that the order that you multiply matrices matters. You do not always get the same thing. So the commutative property does not hold true for matrices. Okay, another little proof that you might have to do in your homework, and I want to show you, discovering another property. Use the matrices R, S, and T to determine if S parentheses S plus T close parentheses times R equals SR plus TR. So that is an example, I know you all know, of the distributive property. So we're trying to see if that is true. So the first thing I'm going to write down is I'm going to copy down and fill in S. So S is 4, 6, negative 2, 5. And T is negative 3, 7, negative 4, 8. And I'm multiplying it by R, which is 2, negative 1, 1, 3. Now, I'm going to go ahead and write the other side, and then I'll work down each side, okay? And I'm using the matrices, y'all, to determine. So it's kind of a proof that you're having to do this in, and you got to show the steps, okay? Is that equal to S times R plus T times R? So I'm just filling them in and asking if they're going to determine. Now I'm going to go simplify each side. So on the left side, if I were to simplify that, what's inside my parentheses, remember to add, we add corresponding elements. So 4 plus negative 3 is negative 1. It's not, it's positive 1. I'll fix that. And 6 plus 7 is 13. Negative 2 and negative 5, that's pretty funny because that's supposed to be a, let's just do this, then you don't see it. How's that? Okay. Negative 6 and 13. Multiplying that by R. And then to multiply that, okay, if it is the long step of something, I'm okay with this. 1 times 2 is 2. 13 times 1 is 13. So 2 plus 13 is 15. And I think I just went ahead and wrote it all out, okay? So 1, this is this right here. So that was first row, first column. First row, second column, negative 1 plus 39 gives me this right here. Second row, first column. Second row, first column, negative 12 plus 13. And then second row, second column, 6 plus 39 is 45. Okay? So now I'm going to go simplify this. So when I add, no, I'm multiplying these two. Okay? So when I multiply these two together, first row, first column is going to give me 8 plus 6. And I didn't do them separately, so I'm going to put this whole thing and talk about it. So I got 8 plus 6, which is 14. Then first row, second column is negative 4 plus 18. Negative 4 plus 18 is right here. Negative 2 times 2 is negative 4 plus 5. It's right here. And the last one, 2 plus 15 is 17. Okay? Then to get my last product, first row, first column is negative 6 plus 7. Negative 6 plus 7 is 1. Okay. Then I have 3 plus 21 to get 24. Negative 8 plus 8 gives me 0. And then 4 plus 24 gives me 8. Then I add my corresponding elements. 14 plus 1 is 15. 14 plus 24 is 38. 1 plus 0 is 1. And 17 plus 28 is 45. So we did prove that S plus T times the quantity of S plus T times R is equal to SR plus TR. So we determined that, yes, that holds true, and that's an example of the distributive property. So just to review, properties of matrix multiplication, okay? The main one that we talked about that is not true, it is not commutative, okay? So the order that you multiply the matrices matters, okay? Associative property, that's the one where we're wondering if what you associate with matters, okay? And doesn't matter when and it is, y'all, associative property of multiplication, because that's what we're talking about. So if it's all multiplication, it doesn't matter if I multiply A times B first or B times C first. Okay? In a scalar multiplication, remember that's a number instead of a matrix. So K is a number, and I can do K times A and then times B, or I could do K times B and then multiply it by A. It does not matter. Okay? The left distributive property is if your scalar is on the left side and you can distribute through, and the right distributive property, which is what we just did above, means that our scalar is on the right side of our matrices. Actually, those aren't scalars. Those are all matrices. But notice in each of these distributive properties that the order didn't change. CA, CB, CA, CB. And if C's on this side, it has to be AC, not CA, because our multiplication of matrices is not commutative. So practice those multiplication of matrices, because you don't want to forget. It's important. So that's all we have. If you have any help, if you need any help, don't hesitate to email me or ask for a Google Meet. Thank you so much, and y'all have a great day.